In this lesson, we're looking at what conditions guarantee that a parallelogram will be a rectangle, rhombus, or square. So in the activity that the textbook kind of has you walking through, it says start by drawing two line segments of the same length that bisect each other but are not perpendicular. So they've drawn that there. And if I connect the ends of the line segments to form a quadrilateral, then I have a figure like what you see next to step B. And then it says measure each of the four angles of the quadrilateral and use those measurements to name the shape. So I pulled up my ruler, but I actually don't need this. I need a protractor. And if I take my protractor and measure this angle, it's 90. Similarly, this angle is 90. And this one up here, also 90. And finally, this angle is also 90. So all four angles are 90 degrees, so by definition, that would make this a rectangle. In this activity, they have you drawing two line segments that are perpendicular and bisect each other, but are not necessarily the same length. And when we connect those dots, look at the figure that we end up with, and they say, here we go, measure each side length of the quadrilateral. Okay, so let's get my handy dandy ruler here. Oh, there it is. And that ends up being pretty close to about 5.5. We'll estimate, that's okay. This one down here, also just about 5.5. When I measure this length, that's also just about 5.5, and similarly, this one here, also about 5.5. So use those measurements to name the shape. And let me come back to this screen because I don't think I did that. In this quadrilateral, all four angles were right angles, so that makes this a rectangle. If I could spell. There we go. And this figure, when we measured all of the sides, they were congruent, and that's the definition of a rhombus. How are the diagonals of your rectangle in step B different from the diagonals of the rhombus in step E? The diagonals of the, oh, that's very strange. The diagonals of the rhombus were perpendicular of different length, whereas the diagonals of the rectangle were not perpendicular, and they were the same length. In the next activity that they kind of have you walking through, they say draw a line segment. At each endpoint, draw a line segment so that 4 congruent angles are formed as shown, and then extend the segments so that they intersect to form a quadrilateral. Okay, so if I extend these segments, if my program would allow me to extend these segments, there's the figure that I get. And it says measure the sides, all right, so we get our ruler out. Oops. And this side length is just shy of 2.5. Right around 2.5. And, you know, account for user error, because that happens. This is about 2.5. And so is this. Okay, so since all of the side lengths are the same, try that again. So the quadrilateral is a rhombus. And when you take into consideration what the original segment was that we started with, in the context of the rhombus that we ended up with, it's a diagonal. And in the diagonal, these 4 angles were congruent. Well, if it's a rhombus, we know that the opposite angles are going to be congruent. And so what ended up happening is that the angles got bisected. Okay, so the line segment is a diagonal that bisects a pair of opposite angles. So we have these properties now. Conditions for rectangles. If a parallelogram has one angle that you already know is a right angle, then you know it's a rectangle. Again, if you have a parallelogram and its diagonals are congruent, then that parallelogram is a rectangle. So let's prove one of these properties. I have that ABCD is a parallelogram, and I know that AC is congruent to BD, so I want to prove that this is therefore a rectangle. So because ABCD is a parallelogram, I'm going to kind of abbreviate a little bit. Segment AB is congruent to segment CD. They're opposite sides of a parallelogram. We are given that AC is congruent to BD. Now, there's multiple statements that you could make using the reflexive property of congruence. So I'm going to look ahead and notice which angles they're talking about later on in the proof. They're talking about this angle and this angle. So if those are the angles that I'm going to be talking about after I say that triangles are congruent, then the segment that I want to say is congruent to itself is segment AD. Because then I can say that triangle BAD is congruent to triangle CDA. Okay, now please notice, I used side, side, side to say that these triangles are congruent. And I'm going further, as you can see, by using CPCTC. And the way that I'm going further is to say that now angle BAD. Please notice the difference. In the previous statement, I said triangles were congruent. Now I'm saying that angles are congruent. There's a difference. Even though they're the same letters, there's a difference. But I know that these angles are supplementary. Because this is a parallelogram, that means BA, or AB as the book says, is parallel to DC. Therefore, the measure of angle BAD plus the measure of angle CDA is 180. And if I substitute BAD in for CDA, then I've got measure of angle BAD plus measure of angle BAD equals 180. And that means that 2 times the measure of angle BAD is 180, so the measure of angle BAD is 90. And a similar argument would show that all the other angles of the figure are also right angles, so ABCD is a rectangle. In this question, we're asked to explain why this is a true condition for rectangles. That if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Well, let's consider the fact that we already are told that this is a parallelogram. So in a parallelogram, opposite angles are congruent. So that means that angle E will be congruent to angle G, and so that makes angle G also a right angle. In addition, angle E is consecutive to angles F and H. So it is supplementary to each of them, making them also right angles. By definition, therefore, a parallelogram would be a rectangle. So now we're using the given information to determine whether we can guarantee that this is a rectangle. So we're told that EF is congruent to GF. And that FG is congruent to HE, and that FH is congruent to GE. Okay, so FH congruent to GE means that the diagonals are congruent. But notice how in the instructions, we're told that this is a quadrilateral. We are not told that it's a parallelogram. So when they told us that EF was congruent to FG and that FG was congruent to HE, that gives us one pair of opposite congruent sides, but not two. So I have no guarantees that this is a parallelogram, and therefore, no. It wasn't first a parallelogram. Next, we have the angle FEG is 45, and that GEH is 50. Well, that means that the measure of angle FEH would be 95. So it is definitely not. And let me amend my answer to number 4 to say not necessarily. Because it could be, but they really just didn't give us enough information. As opposed to in number 5, this is a very much no. They gave us enough information to conclude that it is definitely not a rectangle. We've talked about rhombuses in the last lesson, and here are a few conditions for rhombuses. And earlier it was kind of mentioned what these properties are. That if I have one pair of consecutive sides of a parallelogram that are congruent, then that makes the parallelogram a rhombus. Coming back to the properties that were mentioned earlier, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus, and if a diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So now we're proving one of them. So I'm given that this is a parallelogram, and I'm given a few congruent things. Now, because this is a flow proof, they have a certain order in which things are going. All right, so let's check out all of our given. Here, they have this part. Here, we have this part of our given, which means the other bubble that is asking for a given must be the third part of the given, which is that the measure of angle BAC, or just angle BAC, is congruent to angle DAC. And then let's mark up the diagram with what they've told us so far. I've got angle BCA congruent to DCA. I've got angle BAC congruent to DAC. And since this is a parallelogram, I know these opposite angles are congruent, so let me just go ahead and double arc those. And then I'm saying that AC is congruent to AC, and I hope you still know this property, reflexive of congruence. And so in those two triangles, I have angle, side angle, and the two triangles are the only two triangles in the diagram, I hope you would notice. Triangle ABC congruent to triangle ADC. So, as always, anytime I'm going further than saying that two triangles are congruent, I'm using CPCTC. So I'm using it to say that BC is congruent to DC, and I'm using it to say that AD is congruent to BC. Oh, not BC, sorry. AB. And since I know from over here that this is a parallelogram, let me wait for my screen to catch up. There we go. Since I know that ABCD is a parallelogram, I know that DC is congruent to AB because that's a property of parallelograms, that opposite sides are congruent. So maybe for the purposes of your notes, you want to clarify that. And so that means that BC is congruent to DC by congruent to AB, congruent to AD by the transitive property. And so now that I've said that the four sides of this parallelogram are congruent, now I can say that ABCD is a rhombus by the definition of rhombus. So now we're determining if the conclusion is valid. And in this example, they're talking us through the whole thing, so let me just talk you through it. We are given that AB is congruent to CD, is congruent, BC is congruent to DA. So I know that this is a parallelogram. I also know that AD is perpendicular to DC, and AC is perpendicular to BD. So it says step 1, determine if it's a parallelogram. I've already talked about how those two pairs of congruent sides make it a parallelogram. Step 2, determine if this is a rectangle. And it is because it's a parallelogram having at least one right angle. Determine if it's a rhombus. It is because the diagonals are perpendicular. So since the quadrilateral is a rectangle and a rhombus, by definition, it will also be a square. Similar idea in this example, we're asked, given the information that we are told, can we conclude that ABCD is a rhombus? So I'm given that AB is congruent to BC, and notice what they say. The conclusion is not valid. It is true that if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. But to apply this theorem, we need to know that ABCD is a parallelogram. And the given information is just not enough to draw that conclusion. Here we're asked to draw a figure that shows why the statement is not necessarily true. If one angle of a quadrilateral is a right angle, then the quadrilateral is a rectangle. Okay, so there's a right angle. Okay, I could extend this way out and maybe not make that go so far, or even, I don't have to make that form a 90-degree angle up top. Here's a quadrilateral. It has one right angle. This is very clearly not a rectangle. Finally, in the last example in our video, we're once again asked, can we determine if this conclusion is, or to determine rather, if this conclusion is valid. So it says I know that ABC is a right angle. And can I conclude that ABCD is a rectangle? No, not valid. first know that ABCD is a parallelogram. This lag is really killing me.